Hello students, welcome back to our class. We are going to start a lesson today, that is the structure of atom. So we have covered about elements, compounds and mixtures and about matter discussion. So after that, it becomes important to know about what is the structure of atom. So let's start the session. This lesson will be dealt in parts. So let's start the first session here. So first of all, we need to know about from where the term atom has arisen, right? So in earlier centuries, the word atoms comes from the word atomos, meaning indivisible, and it is coined from a Greek terminology, that is by philosopher Democritus. The very first discussion about matter was done by this Greek philosopher. Then he also said that he gave this idea that universe is made up of tiny indivisible particles called atom. So before the term matter has arisen, it was Democritus who gave the discussion about the existence of things in terms of matter and in terms of these atoms particularly, and he also said that it is indivisible. So atomos means this is a Greek word that is indivisible. Then in 18th century, John Dalton came and he also put forwarded the same idea only, and he was an English scientist. He suggested an atom is the basic unit of matter. We know in today's era that matter is something which occupies space and has mass. Matter is made up of these tiny particles, atoms. It was being said till 18th century by this John Dalton, and he laid the foundation for the discussion of entities with what this matter is made up of. Further, he also suggested, he gave laws or different postulates from his theory, Dalton's theory. Few postulates were that each chemical element is made up of identical atoms, and elements are different because they are each made up of different kinds of atoms. We have learnt in previous lesson about elements, compounds and mixture that they are divided as pure substances and impure substances. Or in totality, if we say that universe first of all is divided into matter and energy, then energy is different aspect. We are only concerned here in chemistry with the matter aspect. So this matter is divided as pure substances and impure substances. Pure substances were being told to you that these are elements and compounds, and this is the meaning and definition being written also, and mixtures are impure substances. So we have learned all these, and John Dalton has also said the same things, that it is made up of identical atoms. Identical atom, when we are saying, for example, oxygen gas, O2. So it is made up of two similar O atoms. When we are saying ozone, so it is having chemical formula O3. So it is made up of three similar identical oxygen atoms only. So this is about elements discussion. And then when we are saying carbon dioxide, water, so these are made up of C and O2, that means one carbon, two oxygen atom. And then in water there are two hydrogen and one oxygen atom, where they combine by their in relation to masses, and those masses are always fixed. We have learned this about in compound definition. According to Dalton, an atom is the smallest particle that can exhibit all the properties of a particular element. So whenever we are saying oxygen atom, that atom is capable of performing all the chemical processes, all the chemical reactions pertaining to that particular oxygen element. And similarly, there will be a molecule also, but the smallest entity is this atom. Originally, it was thought that atoms of an element, they cannot be divided further. But studies in the early 20th century, it showed that atom is itself made up of even smaller particles. So till Dalton gave his theory, it was being said and it laid the foundation that matter is made up of these tiny particles, atoms, and it is not further divisible from the Greek terminology itself. But in the 20th century, several experiments had been performed in order to know the exact structure of this atom and then other certain characteristics. In order to know about that, the scientists came to know about that this atom is further divisible also. And so many numerous subatomic particles are found within this atom. And the three main particles are electrons, protons and neutrons. And besides that, other numerous particles are also present, but we are concerned with these three main subatomic particles. So this was being declared or being cleared in the 20th century. that it is made up of even smaller particles, or you call them fundamental particles or subatomic particles. They are these electrons, protons, neutrons. So one by one we'll be discussing about these. So electrons. So first of all, we are here concerned with knowing that this atom is made up of what? It is made up of these subatomic particles. And now we are discussing the characteristics of these particular subatomic particles. And after that, we will be discussing about that how these subatomic particles are arranged in an atom and how this or these particles, they take part in chemical reactions, because chemical changes, they are involved with the chemical reactions, and these chemical reactions involve these atoms only. And in atoms, when we are saying, so these are these particles only that take part in the reaction. All this will be dealt in detail in further ahead of these sessions, which we will be seeing after this discussion. But right now let's understand the characteristics. So these electrons, first subatomic particle, these are negatively charged particles which are present in an atom, and when we are saying it has one unit negative charge, so you can represent it by small e, and it is negatively charged, so you represent by 1 minus only. Simple, one negative charge it has, one unit, and it carry, these are charged particles, it is negatively charged, no, so it will be carrying some sort of electrical charge in it, and whose quantity is 1.602 into 10 power minus 19 coulombs, and in short you can call it as 1.6 into 10 power minus 19 as well. So it is about the representation for this electron. An electron has mass of 9.1 into 10 power minus 28 grams, and when you are saying in terms of kg, it will become 10 power minus 31, which is 1 by 1837 of the mass of one hydrogen atom. So this much small is it, this particle, so definitely the mass will be very reduced. So therefore these electrons are considered to be having negligible mass, because it is very less when we are comparing one hydrogen atom, because one hydrogen, the smallest lightest element, it has 1.008 something mass, right, and it is 1 by 1837th part of that. So you can easily deduce from this value magnitude that how much small is this particle. So definitely the mass is going to be very small, so you consider it as a negligible mass. Evidences showed that electrons are essential components of all atoms, and these are, yet this is very true, and we'll be understanding when we will be discussing about how the chemical reactions are taking place and how chemical bonding taking place. So there they play very essential significant role. Then second subatomic particle is protons. These protons are having opposite nature of electrons. These are positively charged particles that are present in an atom, and they are equal in number to electrons present in an atom. That means an atom will always have equal number of protons and electrons. This proton is represented by small p with the symbol +1, because it has one unit positive charge, okay, and it will be having same magnitude only, 1.6, this is point, okay, 10 power minus 19 coulomb. This proton has mass equal to one atomic mass unit, which you call AMU, and it is 1.6 into 10 power minus 24 grams. So electron had 9.1 into 10 power minus 28 grams. This proton has mass 1.6 into 10 power minus 24 grams, still very negligible mass, okay. The number of protons in an atom of an element, it helps us in determining the properties of that element, and it distinguishes it from the atoms of other elements, because each element will be having different protons, different number of protons and different number of electrons. That is a term, atomic number, which we will be dealing ahead of in the session only. So this difference in the number of protons gives a unique identity to a particular element. Then the third subatomic particle is neutrons. These are particles with no electric charge, so they are neutral in nature definitely. So neutrons represented by symbol small n, and because they don't have any charge, so you can show it by 0. Simple. This is the representation for a neutron. But it has mass. It has mass equal to the proton mass only. A neutron has mass equal to 1 atomic mass unit, which is almost equal to mass of a proton, that is 1.6 into 10 power minus 24 grams. So neutron, proton has same value of mass. Electron has different, which was 9.1 into 10 power minus 28 grams. Sir J.J. Thomson in 1897, he discovered these electrons by his particular some experiments. These experiments are not part of your syllabus right now. You'll be dealing with these experiments, how these electrons, protons and neutrons were discovered, but in 9th class you'll be dealing with those experiments. Right now just be aware that who has discovered these electrons. So Thomson has performed certain experiment and he concluded the discovery of these electrons in 1897. Robert Millikan was there in 1909. He determined a negative charge on the electron. So these are some conceptual facts related to subatomic particles. Goldstein is there, who discovered protons. Ernest Rutherford in 1911, he discovered that atom has a nucleus. So these all scientists were involved in deducing and in knowing the structure of the atom, that where a particular subatomic particle is present. So from the efforts of these scientists only, the structure of atom has been deduced. Rutherford discovered the nucleus. Electrons, protons were discovered by Thomson and Goldstein respectively. Then there is another important scientist, Niels Bohr in 1913, who discovered electron shells. He discussed and he let us know about that these electrons, they are present in a particular place in an atom, which he called energy shells or electron shells or orbits also. We'll be seeing these terms, so do not get confused or worry that what are these terms. We'll be dealing one by one all these terms. Then there is James Chadwick also in 1932, and he is involved with the discovery of neutrons. So now you know who discovered electrons, protons, neutrons, and the nucleus of an atom was discovered by whom? That is Rutherford. And these electrons are present in special places, that is electron shells in an atom, and this was given by Bohr. These are some important names of these scientists involved in discovery or deducing the structure of atom. These three subatomic particles, that is protons, electrons and neutrons, these are of great importance in understanding the structure of an atom. Various models were put forth to arrange these particles in an atom. So now we'll be discussing that what are these models, with what these have been deduced, that how the particles are arranged in an atom. According to modern standard model, an atom consists of two structural parts. So as I said, model will be discussed in detail in your higher class only, but right now the one specific standard model, what it states that atom has one part known as nucleus and the other part is known as shells or orbits. We have seen the term electron shells. It is that same term. Nucleus is the central part of the atom which contains protons and neutrons. For right now, just understand this only, that atom has two parts, nucleus and the electron shells. Okay, or simply you call them shells or orbits. Nucleus is that part in the atom, specifically the central part, which is made up of protons and neutrons. And shells or orbits are those imaginary paths. You assume these paths. These are circular paths in the empty space of an atom surrounding the nucleus. So these imaginary paths are present around the nucleus, in which electrons revolve around this nucleus, called as orbits, and they have fixed amount of energy also. So these orbits have this fixed amount of energy. This is one simple diagram representing the structure of a carbon atom. So this is this circular part representing the nucleus. Nucleus carbon, its atomic number is 6 and its mass number is 12. You represent an element in this term only. So atomic number, this term indicates the number of protons and number of electrons. Protons, electrons are equal in number, that we have also learned in the previous slides, right? So this carbon has 6 protons, 6 electrons, and nucleus we have learned that it consists of protons and neutrons. Neutrons are calculated by subtracting the number of protons from the mass number. Mass number, as I said right now, that it has 12 mass, right? So 12 minus 6 will give you 6 number of neutrons. So neutrons and protons constitutes the nucleus of an atom. In this case, 6 in each case of this carbon atom. And which is the nucleus? And these are these concentric rings or the path which are representing the shells or orbits in which the electrons will be revolving. So 6 electrons are present and they are also arranged in one specific pattern. Okay, and you indicate that pattern as that first shell will have 2 electrons. So that is why this 2 is represented here, and the second shell will have 4 electrons. In case of this carbon example, carbon atom only. Okay, other atoms will have different representation, and so 4 electrons in the second shell will be showing. So there are consecutive shells. Okay, I hope you have understood that how you represent an atom. An atom in simple terms will be having one central nucleus and it will be surrounded by imaginary paths which are concentric rings in which electrons will be present, and this N represents the nucleus. Just now for this understanding, this is a standard model of an atom. These paths have fixed energy. That is also be concerned about this fact. Now, an atom of hydrogen, the very first element, it contains only one proton and one electron, but it has no neutron. Hydrogen is represented by the symbol capital H, and it has mass 1. It has one atomic number also. Mass is written as a superscript and atomic number is written as a subscript in a symbol of an element. This is one general representation for any element, and in this case for hydrogen. So atomic number, as I said, it is equal to number of protons or number of electrons. So hydrogen has one electron, one proton, and neutrons are calculated by subtracting number of protons from the mass number. It has mass 1, so 1 minus 1 is 0. So that is why mass is represented by capital A. This right now here we are calculating number of neutrons. So in this case neutrons are 0 in case of hydrogen. Mass is represented by capital A and atomic number is represented by capital Z for any element. All other atoms except hydrogen, all other atoms will be having all the 3 subatomic particles. Only this hydrogen has no neutrons, rest all have all 3 subatomic particles. In comparison to the overall size of the atom, nucleus is very small. It is that central part and it's a very small region in the atom. So that is why its mass or its existence, it is existing, but it is very small. If we consider a circular stadium as an atom only, so then its nucleus is no more than a simple cricket ball. From here you can, from this analogy you can understand that what is a nucleus in an atom. Okay, the nucleus makes up most of the mass of an atom. So all the mass, as I said, mass is present or is equal to protons and neutrons sum, right? So, and protons, neutrons are present in that central part of the nucleus. So all mass of the atom is concentrated in that nucleus only because it contains both protons and neutrons. So they are having higher mass than these electrons. Nucleus is positively charged because neutron has no charge. Protons are also present. So proton has plus charge. So nucleus becomes positively charged. And the shells have electrons. So shells have negative charge due to protons for this nucleus. Neutrons are also located in the nucleus, but being neutral, they do not affect the positive charge of the protons. Protons and neutrons, when present and always present in the nucleus together, so we call it another term nucleons. That is another term for total number of protons and neutrons present in an atom. These neutrons that we have discussed. So electrons, protons and neutrons, these are present in an atom and it gives this atom a electrically neutral charge. Atom doesn't, when individually present, it has no charge because number of protons and electrons are always equal in number and neutron doesn't carry any charge. So definitely it is not going to interfere with the charges. So neutrality of an atom is maintained because electrons, protons are always equal in number. They have opposite charges. That is what we are going to discuss now. The number of protons and number of electrons are found to be equal. Protons are positively charged, electrons are negatively charged. We have seen the example of carbon atom. It had 6 protons, 6 electrons, right? Thus we can say they have equal and opposite electric charges. Proton has plus charge, electron has negative charge. Therefore, atom as a whole is electrically neutral. So now we'll be discussing about how the stability of an atom is maintained. Since we know that electrons and protons are equal in number and having opposite charges attract each other. We have learned this in static electricity in physics, right? From the very junior classes only. So these charges, they attract each other and they maintain the stability by maintaining the neutrality of an atom. So this is the thing which attracts them is known as that force of attraction, and that is what being written also, that we know there exists a force of attraction between oppositely charged particles. Thus there is a force of attraction between negatively charged electrons and positively charged protons is present in an atom. Protons are present in the nucleus and these electrons, they revolve around a special path, concentric rings, which you call energy shells or orbits, or simply fixed circular path. Fixed by because these paths, individual circle has particular energy and you call them energy levels or shells. This is one diagram which is saying that how this stability is maintained, because electrons are negatively charged particles and they are continuously revolving in the circular path, right? So charged particle, when revolving in a circular path, it is radiating energy from it. Okay, it happens. And so something which is continuously moving and is extracting, releasing out energy, there will be a time come when it will be left with no energy. So ultimately it will collapse in this nucleus, this electron. But this is being assumed, but this doesn't happen. Atom's neutrality is maintained because electrons are revolving particularly in a fixed energy path. The energy is maintained for that particular shell in which electrons are revolving. So that energy is not going out on its own unless electron has to go or to jump from one shell to another shell. And that happens during chemical bonding, when it has to react with any other atom. Only then it happens. Otherwise, it is normally revolving and the stability is maintained. It is expected electrons being charged, light and in motion, it would gradually come closer to the nucleus and eventually fall into it because they are charged particles radiating energy from it, resulting in the collapse of the atom. But this doesn't happen because electrons revolve around nucleus at a very high speed in the shells or these orbits only, which are associated with fixed amount of energy, also called as energy level. That is what I just said. Speed of an electron is about 1/10th the speed of light. Atoms neither lose or gain energy until external force is applied to them. This external force is that reaction that has to happen during chemical combination. So unless that force is present, they maintain their energy. They will neither lose energy nor gain energy. As a result, electrons do not fall into the nucleus, making the atom structurally stable. So with this, we'll wind up the session here, the part 1 of structure of atom, where we have discussed that how the stability or the subatomic particles of an atom are present in an atom and why do not collapse the atom, how the stability, neutrality is maintained. So we'll be discussing in our next session some other important characteristics of this lesson about atom only, but in our next session. Thank you so much.